Hello Rishabh, we would be starting by 8:45. So yeah, let's start with the workshop. Hello everyone, I welcome you all to today's workshop on how to integrate Temple Wallet for signing transactions. Uh, Soumya sir would be taking today's workshop. He's a blockchain developer working on different types of projects, which includes DeFi and NFT. Hello Soumya sir.
Hello, hi everyone. Uh, okay, so I'll share my screen and we'll start. Uh,
Yes, I
should I
will
start
just
or
make you
like
the
should
host.
we wait for a few more minutes probably for us to join if they're joining?
We can wait for a few more minutes. Meantime, I will make you the host so that you can share the screen.
Sure, sure. I'll share the screen.
Yes. Like, can you check if the share screen option is available for you now?
Yeah, it is coming now.
Yes.
Okay. So I'll just keep the screen shared and let me know when. So it's already 4:47, 8:47. So we can wait for 3 more minutes and start then.
Yes. Yes.
Okay. I guess we can start now. Okay. Hello, everyone. So today we are going to have a hands-on workshop on how to integrate Temple Wallet for signing transactions from your app. So this is not specifically Temple Wallet, but that is the wallet that we'll be using in this like to show the demo and stuff. Uh, so so first question that we want to answer is why like what are the wallets, like what are wallets and why we need to use them in our applications. So a wallet is basically it can be a device, a physical medium, a program, or a service which basically stores your public or private keys for cryptocurrency transactions. So basically, if you guys are already aware of this, but sign a transaction right on a blockchain, your identity is basically your public key, and to sign the transactions, you need to have a private key, right? So your wallet is basically storing these informations most probably securely. Uh, like there are different levels of wallets. There are hot wallets and cold wallets and stuff like that. So depending on what kind of wallet it is, it is probably having some security standards to store your private and public keys in that wallet. So in addition to these basic functions of storing the keys, crypto and a cryptocurrency wallet can provide much more, like functionality to sign transactions, do encryption and stuff like that. Right? Some examples of wallets that you might have used if you're worked on Ethereum is probably MetaMask. It's a pretty popular uh, Web3 wallet out there. Then there are other wallets like Exodus, Mist, and so on. On Tezos, if you have been looking around, you have probably found these wallets like Temple, Galleon, Kukai, etc. Besides these are mostly either web-based or desktop-based kind of wallets. There are other wallets like hardware wallets like Legend Nano or something like that, right? So those are more secure because you can carry them around and they kind of have more security than these wallets. Some of these wallets directly do connect with hardware wallets, so they do integrate properly with one another. So now that we know what a wallet is, why integrate a wallet? So it's basically very simple. So if you have a decentralized application, right, you need the ability to sign transactions, make contract calls, and send cryptocurrency and stuff like that, right? So all these functionalities will absolutely require the private key for the user, right? And let's say there is nothing called a wallet, then how do you do these transactions, or how do you do these, contract calls? You probably have to ask the user for their private key. And then with that private key, you can manually, like your client, your DApp application, decentralized application can sign the transactions or make the contract calls. Right? But that is not secure and that's not user friendly because users won't be carrying around their private keys every time, right? So wallets, on the other hand, if you integrate a wallet, it's much user friendly. The user experience increases rapidly because they can set up a wallet like one time, and then it can be integrated into multiple applications and work out of the box basically. So they don't have to remember their private keys, and there's also security involved because they are not exposing their private keys, so their private keys are secured in their wallets. So these are the main reasons why you want to integrate a wallet. And uh, we'll quickly do a hands-on session for integrating the Temple wallet. Not exactly Temple wallet, but it'll work for any other wallet that is on Tezos right now. So you can see a live demo for the application that I'm going to kind of work on, go through rather, on this website, Tezos workshop.lab, and the source code can be found here. So before going into the actual hands-on coding part, let's talk about a little bit about the resources. So these are the resources that you can take a look at. I'll share the slides in the channel probably, and you guys can take a better look. So we'll be using Taquito as our front-end client to interact with the blockchain, and we'll be using Beacon as our wallet API. So Beacon is based on a standard wallet integration protocol that is on Tezos called TZIP10. You can look at the spec for the TZIP10 and look at what it is expecting from the wallets that follow this standard. So any wallet that follows this TZIP10 standard can be integrated with Beacon. So if you integrate Beacon itself in your application, almost all wallets that are on the platform right now will automatically like work out of the box with your application. So that's what Beacon provides you. So besides that, you can also have specific wallets. You can specifically integrate, let's say, Temple wallet if you want. So Temple or the Matfish guys who maintain Temple wallet have their own SDKs, so client SDK. So you can use that directly and make transactions. But that is like specifically for Temple wallet. So users who are using a different wallet will not be able to interact with your website. Besides Temple wallet, we have other wallets like Galleon and Kukai, right? So these also are TZIP10 compatible, so they follow the standard. So they'll also be automatically enabled if you use Beacon. So let's jump directly into the application that we are going to build today. Okay, so before that, I'll just show the wallets that we are using. So this is a Temple Wallet website. So you can go here and install. So there are different options for the browser that you're using. You can probably install it from the Chrome Web Store or the App Store from different browser itself. And once you set it up, will look something like this. So this is the MetaMask wallet, which is probably something you might have used if you have done things on Ethereum. And this is a Thanos wallet. So the wallet itself, the Thanos wallet, is very much similar to MetaMask. So it's very easy to use. Like if you have previously used MetaMask, that is, the things are very intuitive and it gets pretty like simple when you want to integrate stuff and use it, right? So that's why people are usually using MetaMask and not MetaMask, sorry, Temple Wallet. And it also has features like connecting to Ledger, so it can connect to hardware wallets also. So uh, that's pretty useful in most cases when you have a lot of assets or funds in your wallet. Besides that, we are using Taquito, like I said, for the client. So this is a documentation. So you can just search for Tesos Taquito and you can get onto the documentation and go through it. We are going to do some contract interactions. So you can look at the other APIs, but the most important API that we are going to focus on is the wallet API, which basically shows us how we can integrate Beacon with Taquito, basically. Then we have the Beacon docs itself. So, like I said, so Taquito has their own plugin for Beacon, so that makes things work well with Taquito itself. But you can also, use Beacon itself if you are using some other client, let's say like a client library like Console.js or something like that. So you can use the Beacon SDK and uh, probably somewhere here, yeah, like you can look to the examples and stuff and see how Beacon is doing it. Beacon also the SDK itself also points to Taquito to use, but you can also look at the pure Beacon way of doing it. That provides you a little bit more control of what you want to do. But overall, you'll get most of the features that you need to work with on your application in Taquito itself. Yeah, so besides that, this is the application that we are going to work on today. So this is a very simple basic storage application where you can update the contract storage and the number stored in the contract will be updated. So here I'm going to, let's say, put in 9 as my number and update it, and that will pop up the Beacon modal, basically, which shows me the option to connect the different wallets that are currently there supporting Beacon, right? So you can choose any of them, whichever you have installed. So I only have Temple Wallet right now, but if you have Galleon as a desktop wallet, you can use that. Kukai is a web wallet, you can use that also. And if you have AirGap, like a mobile wallet, that is also enabled here. So I'll just connect to Temple and it will get me to this page. I can select any account and then finally I can make a transaction. So that is what we are going to build today. So this is a transaction page. If I click on draw, you will see the actual transaction data. So in the parameters, you can see the entry point that I'm sending and the value that is 9. So I can just confirm it, and once the transaction is verified, it will update the storage here. So yeah, so that's what we are going to build today. And finally, this is a tzip which you might want to look through if you are interested. So it shows all the different interfaces that the tzip like Beacon supported wallets have to follow, basically. So you can look at these. So all these are mentioned in the slides in the resources section. So you can go through them. I'll share my editor now. So yeah. So here we have so this is a contract code that we are using today. So it's just a very simple contract. So I'm showing the contract code because we need to know the entry point names that we are going to call from our application. So this contract is like just 3 entry points, as you can see, and has the update entry point, the multiply entry point, and the add entry point, which is doing exactly what the name suggests. So there's one single value that is in the storage, and that's an integer. And I'm updating the value and the update entry point, multiplying the value with the value that is coming from the parameters in the multiply entry point, and adding the two values that are coming from the add entry point to the stored value of the add uh, entry point basically. And then finally we have some testing going on here. But yeah, but that's the main part that we need to know. You can also get the source code from this link. I'll just share the uh, in the chat. If you guys are interested, you can take a look at the code itself right now. If I can find the chat button, yeah, cool. Yeah. So moving back to the code base. So this is a simple React client that I have here. Just create React app and you get the boilerplate, right? And besides the boilerplate, I have installed a few specific packages that we need today. So I'll just increase the font size. So first of all, we have the Taquito client itself, which is required. So if I go back to the Taquito docs, you'll see, first of all, you have to install npm install Taquito, and you'll get the Taquito itself. You can also use Yarn if you want. Then you're going to install a wallet plugin. In this case, there are three wallets that are there supported in Taquito itself. So we have the TestBridge, the Beacon wallets, and the Temple wallet. So TestBridge is a very old wallet, probably the first wallet that is there on Tezos, but you won't see applications using that anymore. So most of the users, most of the applications are either using Temple or Beacon wallet right now. Using Beacon is probably the best because you get the support for Temple wallet also, and at the same time other wallets that are there. So after you have installed these two, so these are the only two extra packages that I have with this code base here. So the Beacon wallet and the Taquito package. And once you have the installation, you can start working. So I've distributed the code base. So I've already coded the whole thing because I don't think it will be possible to code the whole thing in a short span of 30-45 minutes. So basically, if you go to the code base, you will find in the source SRC directory, there's a library and then there's an app.js. So app.js is actually the whole application, the HTML part of it. Most of it is pretty simple. It's just a basic form which calls different handlers, right, to make the different contract calls basically. So in the handle event, like we'll probably go to that later on. Let's talk about the library first. So in the library, we have all the other package like wallet specific and contract, like blockchain specific calls that we're making. So in the config.json, we are basically storing the details of the application. So this is here because I wanted to make it modular. So if you deploy your own contract, you can just put in the name of your, like the address of your contract, and if you're deploying it on a different network, you can just put the network in the RPC address for the network that you're using. So I'm currently on Florence. You can use Granada or mainnet also if you want. Then the name and the network basically. So any changes that you do here are reflected in the application, like throughout the application. So that's easy to maintain. Then we have the connect package, connect file, which is basically having the wallet connection code basically, right? So if you look at the code here, quickly go through the code, right? So first of all, we are importing the Taquito, the Tezos toolkit and the Beacon wallet objects, like classes from here. And then what we are doing is like we are setting up the objects that we need. So we have first of all, we are forming the Tezos toolkit, using the Tezos toolkit to form a Taquito object that is going to actually talk with the blockchain, right? So if you have worked on Ethereum, you probably know about wallets like MetaMask, which inject Web3 objects into the browser, like into the web page itself. So you don't actually need to have an RPC link or anything like that. You don't have to have a custom RPC to interact with the blockchain. So you can make, you can read the storage or read the contract data and make contract calls directly from the wallet. But in Tezos, the wallet is majorly used for just signing transactions and making contract calls. So if you want to read the storage, you need to have an RPC and have a client that reads the data from that RPC. So that is what this Tezos toolkit is doing. So this Tezos toolkit is going to be used as the main glue to read the storage and also connect to the wallet, because Taquito does allow you to integrate the wallet directly into the Tezos object that we have created here. If you're using other clients like let's say console, then you won't be able to integrate the wallet directly into, like, because you don't have the uh, plugin with that probably, so you won't be able to directly integrate it with the client. So you have to use a separate beacon SDK that I was talking about, right? So you have to use a separate beacon SDK to make the uh, contract calls and transactions on the blockchain. And if you want to read the blockchain storage, or get some big map data or something like that, then you have to use the client that you have created with that package. So yeah, so coming back to the next function, that is a connect beacon wallet, which is basically setting up the options for the beacon wallet. So the beacon wallet takes a set of options that you can provide. So I've just used these three, but if I go back to the documentation, probably here we can see. So yeah, so here we can see the name, the icon, the preferred network, and the event handlers. So the name, these are pretty much self-explanatory. So the name is basically the name of your dApp. The icon is the icon for your application, right? And the preferred network is the network that will be connected to. So you can have mainnet or something like that also in place of Florence. Then comes the event handlers. So Beacon provides an option to trigger specific actions on different events. So permission request is request success is basically triggered when the wallet pop-up comes in and you agree to that, like give permission for the application to connect with the wallet, right? So that is what permission request success event is. And there are other events that are there. So if you look at the examples here, you could probably get it somewhere if I can. Uh, yeah, it's in the beacon documentation itself, so you have to probably find it and see. So there are a lot of different events that you can use with beacon and use it if it's required. So in this simple example, I'm not using the events at all, but you can set it up if you want. Then secondly, we have the beacon object, which is basically you creating the like the beacon connection, like the wallet object, which is going to be then used to get the permissions and stuff, right? So this is taking the options and then creating a wallet uh, object basically. So in this thing, I have done a wallet disconnect before, because what beacon does is like it will cache whichever wallet you choose. So let's say I pick up temple right now, and it will basically store it as a preference in your browser. So either you have to clean your browser cache, or do a wallet disconnect if you want to get that big pop-up of choosing a next new wallet next time you reload the page. So yeah, so that's why I have the disconnect. I'll show you the difference between having a disconnect and not having a disconnect, so that will be useful. Then finally, this is the part where we are asking for permission from the user to connect to their wallet. So request permission is going to give me that pop-up of the Temple wallet pop-up that you saw for choosing the account which needs to be connected to the browser or the application. And once the user gives permission, the application will have access to the wallet instance. So yeah, so that was the wallet connection part. Then finally we have the interact part, which is basically where we are making the contract calls, right? And this is where you need to remember the entry points that we had mentioned before. So I have created separate functions for each of the entry point that is there. So we have an update function, we have a multiply function, and an add function. All of these functions take a Tezos instance. So this is the actual Taquito client that is being taken up, and the value of the basically the parameters that you want to send. So uh, we have the value here, and then set status is basically a callback to update the UI. That's all. So while making a transaction call, right? So when you are trying to make a transaction call, what you'll do is like you'll have to use a wallet instance of the Taquito object. So if I go back to the Taquito documentation. So documentation is the most important. So whenever you face issues, go to the documentation. You'll probably find reference to the issue that you're facing, right? So if I look through the documentation, I think if I go to connect Tezos wallet. Let me just scroll down a little bit. Yeah. So you can see that this making transfers, right? You can also probably look at the transfer to a smart contract. So we are using the wallet instance of the Tezos client. So this Tezos client is basically the Taquito object that we created at the beginning, and this is being used because we have connected a wallet. So if we were not using a wallet, and let's say we are using a raw RPC, just RPC directly. So if I go back to some other example, you'll probably see it's using something else. So if I just do without a wallet, like a normal connection with, let's say, my private keys directly using a soft signer or something, then the Taquito object that you're going to use, like the thing that you're going to use to make the call is a contract thing. So Tezos.contract instead of Tezos.wallet. And that is the only difference between a wallet connection and a normal, private key or in-memory signer thing. So if I look at the other steps, like the other things that are going on here, apart from the wallet thing, is like I'm getting the contract that is there at the particular contract address. So this is basically fetching the contract from the blockchain and reading all the entry points and the parameters that are required and stuff like that. And finally, I'm using the contract object that is being provided, and I'm calling the methods or the entry points that are there on the contract, and finally making the call to the particular contract entry point that I want to call, right? In this case, the update entry point. And I'm sending the value here. So this value, so like if you have multiple values, you'll just keep on putting a comma and then adding the values that you want to send to the contract. So in this case, I just have a single value, so that's why I'm just sending it like this. And finally, send will make the transaction call. So when this call happens, send call happens, it's going to pop up the wallet because I'm using the wallet object again. And once the wallet pops up, you're going to see the, like I showed, the parameters and stuff, and then you can just click on verify or give permission, and then the transaction will go through. Then the following steps are basically waiting for confirmation, and once the confirmation is provided, we just get the hash, and you can look at the indexer to see the transaction. That's all that is going on in this code. And similarly, the all the other functions like multiply is also doing the same thing, getting the contract, calling the multiply entry point with the value, and waiting for confirmation. The add function takes two parameters. So here you can see that I'm passing it as a comma b. So if you have multiple other parameters, you can just put a comma b comma c, and keep on going for the entry points like parameters that are there. Apart from that, there is nothing special in these functions. Finally, we have the get value function. So this is basically getting the storage instead of the contract, like making a contract call is going to, instead of calling the methods on the contract, it's getting the storage. And once the storage is there, it just reads the storage. So in this case, the storage is just a single integer. So you don't have to parse anything or do anything specific. But if you have a, complex storage, let's say like a, let's multiple, you know, values in the storage, then you'll probably get a JSON formatted thing. So you have to probably look through the form JSON and get the data that you specifically want. So yeah, so that's all for the library part, and this is mostly the most important section of this like integration part, where you are connecting the wallet and finally making the contract calls using Taquito. In the app.js, where it all is bound, like glued together, I'll just go to the top and then talk about it. So apart, like there are some things like the state variables that are there. So basically, this is a Taquito client, like the Tezos object that I was talking about, which is going to be set once the user connects the wallet. And the most important is probably the handle event, where we are making the call to the contract, right? So whenever the user clicks on a button on the form, this function is being called, and we are always, so in this case, I'm making a call to the like connect wallet always, because I want to get the wallet pop up to choose the account and stuff. But what you can do is, like, you can just connect the wallet only once, and you are good to go for that particular session. So you don't have to connect the wallet every time. But in this case, that's what I've done. When you connect the wallet, you get the wallet object, and to enable the Taquito client, right? The Tezos object that you saw, to use the wallet, you need to call the set wallet provider and pass in the wallet object that you have created. So in this case, I'm just calling the Tezos.set wallet provider and passing the beacon wallet object that I created in this function, and I'm passing that wallet. And finally, after that happens, you can just call the particular function that needs to be called, and it will just make the transaction for you. So if you have issues with the code base, you can probably take a look at the code base and let me know. I can clarify the any comments or issues that you have. So I'll just start off the uh, client here, and we can see it working. Are there any comments in the chat? Okay, so yeah, so the page is loaded, and yeah, someone has already sent over a huge number. Anyways, so in this code base, you'll see that I have commented the connect disconnect thing, right? So now if I connect my wallet, it is actually already connected. So you won't be, if I'm hoping it's already connected. Yeah, it's already connected with Temple. So it directly pops the Temple wallet uh, pop up, right? It doesn't show me the option to connect to a different wallet anymore. So I can just choose any of the accounts that I want, and let's say I want to choose this and connect. And once the connection happens, I get the permission thing to do the transaction. So that's the only difference. So if I have the disconnect on instead of off, it will disconnect the wallet and it will give me that wallet pop-up. So that's the only difference of having the wallet disconnect and not having the wallet disconnect in the code. Apart from that, it's mostly the same. Cool. Okay. So I think it was a pretty short session. We can have a Q&A and discuss any doubts or anything that you guys have. You guys can take a look at the code, and probably we can talk about that.
Yep, I had it out.
Yep, I'll just stop sharing first. Yeah.
Yeah. While deploying this contract, did you deploy it via the SmartPy ID or did you use Truffle? Something else?
So, okay, first of all, I don't think Truffle supports Tezos. I
Yeah,
might be wrong.
exactly. Yeah.
So Truffle probably doesn't support this thing. So what you can do, so
SmartPy.
yeah, so yeah, obviously SmartPy is one way of doing it. It's pretty simple. So if you're just getting started, SmartPy is probably the best to deploy the contract. But what you can also do is, like, you can use Taquito to deploy the contracts. So Taquito also has a contract like origination. If I can find, yeah, originating contracts. You can take a look at this code, what they are doing. So it's basically taking the compiled stuff and deploying it. Like, you can call tezos.contract.originate, and it will basically originate the contract for you. So you
All
can
right.
automate the code, like automate it using the Taquito client also. So that's what's possible.
Right. And another one is there any beacon for Flutter? Like this is for React, right? The keto and all that. It's for
So
JS.
Flutter, so mobile devices do not have like that. Like, you can say this is a browser plugin, right? So it won't
Yeah.
work with mobile devices like that. What you can do is, like, Beacon does support. Like, I don't know how useful that would be for mobile applications. Like, let's say this one, right? So when I disconnect, right, so I get this pop-up, right? So you can pair with a wallet on another device, or for example, the AirGap wallet also. These are mobile wallets, right? So if you click on this, you'll get a QR code, right? And any wallet that supports this beacon format, right? Beacon standard, that TZ10, can scan
Yeah.
the QR code and connect with this thing. And once it's connected, right, all your requests are going to go to that particular wallet itself. So if you're on a mobile device, you probably will have to somehow, if it's on the same device, right, if the mobile wallet and the application are the same device, it might be a little difficult to scan the QR code. But if you have a separate device or something, then you can probably scan it and use it. But I don't think it's a good idea of doing it. So I'm not sure, like, if there's any other better way of doing it on, having a wallet integration on mobiles right now on Tezos, because most of the applications I have seen that are mobile applications either use the in-memory signer, which is basically taking the private key from the user and then doing it, So that's
All
probably,
right.
this is probably the only way you can integrate the beacon wallets with your mobile
Right.
application.
So, right till up till now, the most common use thing is to ask the user for the keys, right?
Mhm.
For
Yeah,
mobile applications.
right, right.
All right. Thank you.
Yeah. You can take a look at like if you're working on a project, right? That could be a good project also for not just you but anybody who's planning to work on wallets or something. You can take a look at on Ethereum. There's something called Wallet Connect. I think that allows you to even connect wallets on mobile phones, like and mobile devices. So you can take a look at how it works and if it's possible to do it on devices also. That would be a very
All right.
useful feature to have.
All right. All right. Thank you.
Anybody else? Okay, I guess nobody else has any questions.
Yes. So I guess we can close the session. Is anyone having any doubts?
So yeah, like last call, if anybody has any questions, you can probably ask now, or also you can ask in the channel. I'll probably be there also. So yeah, no worries.
So thanks a lot everyone for attending. Thank you so much, sir, for being here.
Thank you everyone for being
Thanks
here.
a lot.
Bye. That's all.